Okay, hello guys. Today we are talking about the geometry and the vectors part, okay? So let's move into the first part about the vector basics and the column vectors, okay? So first of all, let's investigate what is the differences between two brand new words, scalar and vector, okay? So for the first word, scalar means there's only magnitude meaning in this, okay? So for example, like mass. So here, most of the time we said our mass is for 5 kilogram, right? We doesn't said like my mass is 5 kilogram on the left or my mass is 5 kilogram on the right, right? So there's no direction on the mass. So there's only the magnitude or only the number to represent for the value of the mass, right? Okay, that is the first example. And for a second example, we can set a temperature, right? So temperature here is 20 degrees. We never said temperature is positive 20 degree or like temperature is 20 degree on the left or 20 degree on the right, right? So we can say that there's only represent for the magnitude or the size, okay? So also distance, like most of the time we say distance is 10 meter. We doesn't say the distance on the left is 10 meter or distance on the right is 10 meter, right? Okay. But vector is quite different. We said vector means that it has both magnitude and direction. Okay. So for example, like here we said force. Like force, we can say it is 10 Newton downward. Okay. And maybe for here, velocity is 60 kilogram per hour on the north. Okay. And displacement here is 10 meter to the right. Okay. So we can say here that vector means both magnitude and direction right here. Okay. So here we have the vector notations right here, okay? So maybe from A to B point, we can say that there's a vector, okay? So we can using the endpoint to represent for a vector. Like here, we are using an endpoint from A to B like this way, okay? It means the movement from A to B, okay? And also we can using a lowercase to represent for the vector, like we can using smaller a to represent for the vector AB, okay? So also we can using a handwritten letter under it, like a timeline, like A right here, okay? But most of the time we're using smaller capital, smaller letter A and endpoint AB to represent for this, okay? So we can say that is an arrow, right? So we can just put into the coordinate. Okay, so here we can say if this is the original point for the vectors first of the beginning, and this point is x and y, we can just using a column like here, and we added two words right here. So first number x just means the x-axis for the end of the arrow, okay? So y here means end of the y-axis of the arrow. Okay, so here we can find if 0 is 0, 0, that the end here is for 3, 2, right? But you can find here the 3, 2, the coordinate just lies down, but with the xy here just becomes a column, okay? So here we have to write that as 3, 2, okay? So here we can use a smaller letter v to represent for vector, that is 3, 2. Also, if you name the two ends, you can say it's a and b, that is vector using an endpoint ab as 3, 2, okay? So here we can just calculating or just to find or figure out what is a column vectors, right? Okay. And here we can say we have equal and parallel vectors. You can find here. First, we have a blue arrow, and on the right, we have a red arrow. Okay, so one is A and one is B. So we can say they're both 2, 2, right? So they're from the original point to the another point. Like here, you can find maybe A point and B point. You can find B point on the right, 2 units of the A, and also upward 2 units of the B, right? Okay, so we can say A is for 2, 2. And also vector B is also 2, 2 because here you can find the first point to the final point just moving right to 2 units and moving up for 2 units, right? Okay, here it is. So we can set the conclusion that they have the same direction, they have the same magnitude. We can set the two vectors A equals to the next vector B, okay? That is his. And also we have negative vectors, okay? Like here we can set the vector from A to B here. That means we first moving up to right for 3 and moving up for 1, okay? So here vector can be written as 3, 1, okay? That is a column 3, 1. And if you just direction moving to here, that means you first moving downward for negative unit and moving left for 0 unit. So here is for -3 and -1, okay? So we can say that there are two same length or same size vectors, but they have the same different direction, right? So we can say BA, like vector equals to negative a vector AB, okay? That is it. So we can say maybe here they have the same endpoint and they have the same size, but they have a very quite different or opposite direction, okay? So maybe here vector A A is equals to negative vector AB. Okay, they're quite different. Okay, that is all negative vectors right here. So also here, we have a deliberate practice for you. So you can first try on yourself and pause the video. But if you want to follow with me, you can keep on going. Okay. So let's move to the first problem. Like here is that a vector moves 5 units left and 2 units up, and write this as a column vector, right? Okay. So first we said 5 units left and 2 units up. So here we can say the column vector here is for -5 and 2, right? So here we can say the column vector we have to write down as the column like handwritten. So here is column -5 and 2 inside. And for second problem, you can find first endpoint from P to Q is -4, 7. And we have to write down the column vector for vector QP, right? So here, please remember that it is reversed. So -4 can be written as 4 and 7 can be written as -7, okay? So here, vector QP can be written as 4, -7, okay? That is for second problem. And for third problem here, A is 2, 3, and B is 7, -1. So we get the vector AB here can be written as -1 minus 3 and 7 minus 2, okay? So it can be written as -4 and 5, okay? That is for vector AB, okay? And for the fourth problem, vector M equals to 3, -2, and vector N equals to 3, 2. So the question is, are they the same vector? But we said vector have the same direction and the same magnitude, right? So maybe here we have the same magnitude, that is it. But you can find here that they have a quite different representation of the M and N, okay? So we can say they're quite different, or they're just a different vector, okay? So we can say here, because 3, -2 doesn't equal to 3, 2, because here's -2 and here's 2, right? So only 3, 2 and 3, 2 can be considered as the same vector. We can just draw a coordinate. Here is for 3, -2, and here's for 3, +2, right? So they're quite different. The arrows are not overlapped, right? So we cannot say that they're the same vectors right here. Okay, so that's for today's our total lesson. I hope you can just understanding how to draw the vectors and how to understanding for the column vectors. Okay, so we cannot write them as a coordinate, but this way we can just understanding what is a column vector. Okay, so that's for today's our lesson. See you next time. Bye.